Theorem Theorem 3. The perpendicular drawn from the vertices of a triangle to the opposite sides are concurrent. Here you see this is a triangle, and perpendiculars, that is altitude, we can also say altitude, perpendiculars drawn from the vertex of the triangles, they are concurrent, means they passes through a point. So given let ABC be a triangle, let the perpendiculars BE and CF drawn from the vertices B and C to the opposite sides CA and AB meet at P. Join AP and produce it to meet BC at T. To prove that AD is perpendicular to BC. Now construction through A, B and C, straight lines are drawn parallel to BC, CA and AB respectively, and they form triangle XYZ. Now proof. See, through A line is drawn which is parallel to BC, and again through B a line is drawn parallel to AC, and through C a line is drawn parallel to AB. So they intersect and form a triangle Z. Let me draw the figure again here, clearly for you. See, this is the triangle ABC, ABC, and F here we have stated that BE and CF, the perpendiculars BE and CF are drawn from the vertices B and C to the opposite sides CA and AB. That is, BE is perpendicular to AC and CF is perpendicular to AB. This is given. And BF and BE and CF, they intersect at P. They intersect at P. BE and CF, BE and CF, they intersect at P. Now AP is joined and is produced to D to intersect BC at D. Now through A, a line is drawn. Through A, a line is drawn. A line is drawn parallel to BC, and through B, a line is drawn parallel to AC, and through C, a line is drawn parallel to AB, and they intersect at X, Y and Z, and they form a triangle. Now you see that here you see proof. A, B, C, Y. See, since XY is parallel to BC from construction, therefore AY is parallel to BC. Again, since ZY is parallel to BA, this is also from construction, so ZY is parallel to BA from construction, so CY is parallel to B, CY is parallel to BA. Therefore, we can say that A, B, C, Y is a parallelogram. Similarly, we can also say that ACBX is a parallelogram. Now here, since ABCY is a parallelogram, therefore AY is equal to BC, because opposite sides of a parallelogram are equal. Or you can write clearly parallelogram. Opposite sides of a parallelogram are equal. Again, AX is equal to BC. Again, opposite sides of a parallelogram are equal. So this is equation 1 and this is equation 2. From 1 and 2 we get that AX is equal to AY. Therefore AX is equal to AY. Again, similarly, Similarly, bx similarly your bx is equal to bz and cy is equal to cz. Therefore, A, B and C are the midpoints, they are the midpoints of xy, xz and yz. They are the midpoints. Now you see here you see that one thing I have to do here, 1 minute I have to do something. Here you see that A, B, C are the midpoints of xy, yz and xy, A is the midpoint of xy, B is the midpoint of xz and C is the midpoint of yz. Now you see that since AC is parallel to xz, which we have got from construction, we have got this. Therefore, your angle CEB is equal to angle EBX equal to 90 degree. Here you see CEB, this is equal to EBX, they are equal 90 degree because alternate angles. Therefore, we can say that BE is the perpendicular bisector, perpendicular bisector, not as perpendicular bisector of xz. Again we can also say that FC is the perpendicular bisector of yz, because you see here that is AB is parallel to xz, therefore your AFC, this angle, or BFC, this angle is equal to FCY, alternate angles, so both are 90 degree. So I can say that CF is the perpendicular bisector of yz. yz. Thus Thus, the perpendiculars, the perpendicular bisector BE and CF of the sides XZ and YZ respectively meet at P. Hence the perpendicular bisector of XY must also pass through P, that is we can say that AD is perpendicular to XY, that is AD is perpendicular to XY, or AP is perpendicular to XY. AP is perpendicular to XY. Let me write this first. That is AP is perpendicular to XY, or AD is perpendicular to XY. Therefore AD is perpendicular to BC. Proved. Now let me repeat you again. Here what we have done, you see. Here what we have done, you see. First of all, there is a triangle ABC. Now the theorem states that the altitudes drawn from the vertices of the triangle, they are concurrent, that means they passes through a point P. So how we have proved it? ABC is a triangle where BE is perpendicular to AC and CF is perpendicular to AB, and this BE and CF, they intersect at P. AP is joined and produced to D to intersect at BC. Now we have done a construction. We have to prove that AD is perpendicular to BC. We have to prove it. So what we have done a construction. Through a line is drawn parallel to BC, and through B a line is drawn parallel to AC, and through C a line is drawn parallel to AB, and these lines intersect at X, Y, Z, and they form a triangle XYZ. Now you see here that since XY is parallel to BC, therefore automatically AY is parallel to BC. Again, since BA is parallel to ZY from construction, so automatically BA is parallel to CY. So ABCY is a parallelogram. That is, if the opposite sides of a quadrilateral are parallel, then they form a parallelogram. Again, similarly, therefore AY is equal to BC because opposite sides of a parallelogram are equal. AY equal to BC. Similarly, XA is parallel to BC and XB is parallel to AC. Therefore, XACB is a parallelogram. So XA is equal to XB. From these two statements we get that XA is equal to XY, that is A is the midpoint of XY. Again similarly we can prove that here you see ABZC is a parallelogram, therefore AC is equal to BZ. Again ACBX is a parallelogram, therefore AC is equal to XB. Here again I am repeating it. See, ACZB is a parallelogram, therefore AC is equal to BZ. Again ACBX is a parallelogram, therefore AC is equal to XB, because opposite sides of a parallelogram are equal. From these two statements I get XB is equal to BZ. XB is equal to BZ. So B is the midpoint of XZ. Similarly, C is the midpoint of YZ. Now, here you see AC is parallel to XY. AC is parallel to XY from construction, and BE is the transversal. So angle CEB, this angle is equal to XBE. They are alternate angles. So BE is perpendicular to XZ. Again here you see AB is parallel to YZ and FC is the transversal. So BFC is equal to FCY equal to 90 degrees. They are alternate angles. So your CF is the perpendicular bisector of YZ. CF is the perpendicular bisector of the YZ. Now these two perpendicular bisector intersect at P. It is given. So automatically AD, since AD passes through P, so automatically AD must be the perpendicular bisector of YZ. Again, since AD is the perpendicular bisector of YZ and AD is the perpendicular bisector of YZ and BC is parallel to XZ, so AD is perpendicular to BC. Or we can say AP is perpendicular to XY. AP is perpendicular to XY. So AD is perpendicular to XY. So AD is perpendicular to BC. So here this is the conclusion which I have drawn here. Hence the perpendicular bisector of XY must pass through P. So because the perpendicular bisectors of a triangle are concurrent, which is stated in theorem 1. So AP is perpendicular to XY, so AD is perpendicular to XY, and since your XY, since XY is parallel to BC, therefore AD must be perpendicular to BC. This is proved. Now I am going to the next theorem. Your next theorem is here. This is your next theorem. See the next theorem. Theorem 4. The medians of a triangle are concurrent. The medians of a triangle are concurrent. The medians of a triangle are concurrent. That is, you see this. The medians of a triangle are concurrent. A, B, C, this is the triangle. The median A, D, B, E and C, F, they are concurrent. So given, what is given? let the two medians BE and CF of triangle ABC meet at G. Let AG be produced to meet BC at D. To prove that AD is the median, that is, D is the midpoint, of BC. So there is a construction through C draw CK parallel to BG to meet AD produced at K join BK. So I am drawing the figure again. See, ABC, this is a triangle. BE and CF are the medians. They meet at G. AG is produced to meet BC at D. This is your G. Now there is a construction through CK is drawn parallel to BG. CK is drawn parallel to BG to meet AD produced at K, and BK is joined. Now proof. Here the proof is see the proof. In triangle ACK, this is the triangle ACK, in this triangle ACK, here you see E is the midpoint of AC, AC, and midpoint of AC. Why? Since BE is the median, because BE is the median, B is the median, E is the midpoint of AC. Why? Since BE is the median. Now again, GE is parallel to CK. Why? Since your CK is parallel to BE from construction. This is from construction. This is from construction. This is from construction. So G is the midpoint of AK. Therefore, G is the midpoint of AK. Why? This is the converse of Bpd theorem, a line drawn through the midpoint of a side of a triangle parallel to base bisects the third side. So G becomes the midpoint of AK. Again, in triangle ABK. Now, in triangle ABK, say G is the midpoint of AK, which we have proved, and GB is parallel to CK. Why? Since CK is parallel to BE from construction. From construction, one thing, it would be better in the construction. One thing, it would be better. CK is parallel to BG. CK is parallel to CK is parallel to BG. CK is parallel to BG. CK. It will be better if we write like this. CK is parallel to, instead of BG, it will be better if we write GB instead of CK. It will be better parallel to GB, because the direction CK is parallel to GB, because the direction I have given here CK GB. So here also, since here it will be better if you write, instead of GE, if you write EG is parallel to CK, since CK is parallel to GB, since CK is parallel to GB. CK is parallel to GB. CK is parallel to GB, and it is. So again here, it will be better if we write GB is parallel to CK, since CK is parallel to GB. I have done this correction because I have given here this sign in the direction CK, so and GB. So it will be better if we write CK is parallel to GB. So I have done the correction here. Through C, draw CK parallel to GB. CK parallel to GB. This would be better if you write, because I have given the direction here in the direction CK in GB. So here also, here this direction. So EG is parallel to CK. Why? Because CK is parallel to GB, and BG is produced to E. So since GB is parallel to CK, therefore this whole line is parallel to CK. Therefore this is also parallel to this CK. And here also I have made this correction, because I have given the direction here in the from C to K, G to B. So GB is parallel to CK, and since CK is parallel to GB from construction. from construction in triangle. One minute. There is a slight mistake I have done. G is the midpoint of AK. Okay, I have done slight mistake. Remove this. This is the mistake I have done here. In triangle ABK, in triangle ABK, G is the midpoint of AK. We have already proved, and F is the midpoint, and F is the midpoint of AB, and F is the midpoint of AB. This is given. This is given. Here you see given. Let the two medians BE and CF of triangle ABC meet at G. I have told here CF, median CF, therefore F is the median of, is the midpoint of AB. So F is the midpoint of AB given. Therefore your therefore your GF, this GF is parallel to KB. 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 So I can state here GF is parallel to AB. So therefore your CG is parallel to KB. Now why GF is parallel to KB? This is midpoint theorem. This is midpoint theorem. According to midpoint theorem, line joining the midpoints of any two sides of a triangle, line joining the midpoints of any two sides of a triangle is parallel to the third side. So from this, therefore GF is parallel to KB. Therefore GF is parallel to KB, because G is the midpoint of AK, F is the midpoint of AB. So in triangle ABK, these two are the midpoints. So this is parallel to this. So this is parallel to this. Therefore this is parallel to this. Therefore this is parallel to this. So now what we get? We get that here you see GB is parallel to CK. GB is parallel to CK. GB, GB, GK. Here we got okay. See, that's okay. One thing here you see. GB is parallel to CK. GB is parallel to CK we got from construction. We got GB. This GB is parallel to CK from construction. And now here CG is parallel to KB. CG is parallel to KB. Therefore, I can say that BKCG is a parallelogram. Therefore BD is equal to DC. Why? Since diagonals of a parallelogram bisects each other. So BD is equal to DC. Therefore D becomes the midpoint. Therefore D is the midpoint of BC, and so therefore AD is the median. AD is the median. Now point G, this G point G is called the centroid. The point G is called the centroid. Point G is called the centroid, and AG is to GD. AG is to GD. AG is to GD. The ratio is 2:1. How 2:1? I can prove it. How 2:1? See, since you see AG is equal to GK, because G is the midpoint. G is the midpoint of AK. G here I have proved here. G is the midpoint of AK, and again GD is equal to DK. Here you see GD is equal to DK. Why? Diagonals of a GD is equal to DK. GD is equal to, this is D, DK. Why? Diagonals of a parallelogram bisects each other. So therefore AG is equal to GK. AG is equal to GK means GD plus DK. GD plus DK. GD plus DK. GD plus DK, which implies that AG is equal to, since GD is equal to DK, GD is equal to GD plus GD, which implies that AG is equal to 2GD. Therefore AG by GD is equal to 2/1. So I am again giving you the, I am again explaining you how we have proved it. Here you see ABC is a triangle, and the theorem states that the medians AD, BE and CF, they are concurrent. That means they passes through a point. So what we have done, we have considered BE and CF are the medians, and they intersect at G. AG is produced to D, which AG is produced which intersects BC at D. Now we have made a construction. We have to prove that AD is the median or D is the midpoint of BC. We have to prove it. So what a construction has been done, through C a line is drawn parallel to GB. Through C a line is drawn parallel to GB, and AD is produced to intersect at K. Now in triangle your ACK, in triangle ACK, E is the midpoint of AC, it is given to you, and EG is parallel to CK. EG is parallel to CK. Why? Since GB is parallel to CK from construction. So EG is parallel to CK, therefore AG is equal to GK. This is a line drawn through the midpoint of a side of a triangle parallel to the base bisects the third side. Now, um, in triangle ABK, G is the midpoint of AK and F is the midpoint of AB. This is given. So GF is parallel to KB. Why? Line joining the midpoint of any two sides of a triangle is parallel to the third side. So GF is parallel to KB. Therefore, CG is parallel to KB. So CG is parallel to KB and GB is parallel to CK from construction. So your GBKC is a parallelogram. GBKC is a parallelogram and therefore BD is equal to DC because diagonals of a parallelogram bisect each other and therefore AD is the median. And G is called the centroid of the triangle and AG is to GD is this 2:1 ratio. This is the proof. One thing I want to tell you that in theorem 3 I have proved it, but the point P, this is called point P. Point P is called the orthocenter. Point P is called the orthocenter of triangle ABC, and your DEF, this triangle, this triangle, DEF is called the your triangle. DEF is called paddle triangle. DEF is called the paddle triangle. DEF is paddle triangle, or it is also said as, here you see DEF, this is DEF is called the paddle triangle or orthocentric triangle of triangle ABC. Orthocentric triangle. Here DEF, this is called the paddle triangle or orthocentric triangle of triangle ABC. This is all about the theorems which is given in plane geometry.